Hello everyone, this is Dr. Lennon. Welcome back. So at the very end of last time we wrote down the quadratic formula, which gives us the solutions to a quadratic equation of any type. So remember that formula is basically the idea comes from completing the square, but it kind of takes care of it all for us and does it in one easy step. You just have to remember this formula: x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, I may or may not give that formula to you on like an exam. I haven't decided quite yet, but the mistakes generally come from a couple of places. So this b squared, if b happens to be a negative number, you need to put it in parentheses, and we'll see that on the first example we do. And 2a, a lot of times people will forget to put the fraction bar underneath the over everything. So negative b is also being divided by 2a. So those two things usually cause problems on the simplification. So let's look at an example. An example might look like this. Let's say solve 3x squared minus 5x minus 1 equals 0. And you know, completing the square is great, but we run into quadratics so frequently in practice, it's just good to be able to jump right to the answers, which is what the quadratic formula does. So this is already set up with all your numbers on the left-hand side and 0 on the other. So we identify the constants. So a would be equal to 3, the coefficient of x squared. B would be equal to negative 5. And c would be equal to negative 1. So what we do is we just simplify. So x is going to be equal to, okay, so it's negative b. B is already negative 5, so that means this is actually just positive 5. So negative b is positive 5. And then we do plus or minus, and then we have to do the square root. Okay, 5 is a negative number. We're squaring negative 5 though, so negative 5 needs to be in parentheses. The point is, if you do, say you're trying to do this in your calculator and you type in negative 5 squared, which is correct, that actually means positive 25. But if you would do, say, negative 5 squared like this, if you type that into your calculator, due to order of operations, the square happens before the negative takes precedent. So this would actually be negative 25. So your answers are 50 apart in this one simple example. So it's going to throw your answer a ton by missing out on those parentheses. Okay, then we need to subtract 4 times a, which is 3, times c, which is negative 1. So those two negative signs are actually going to make this a plus. And then we divide by 2 times 3. So this would simplify to x equals 5, and then just simplify your numbers underneath the square root. So negative 5 squared is positive 25 plus 12 over 6. And then we end up with x equals 5 plus or minus the square root of 37 over 6. And those would be your two answers. So, you know, again, we could write them as 5 minus the square root of 37 over 6, and 5 plus the square root of 37 over 6. And we could give an approximation for each of those numbers. They come out to about negative 0.18 or 1.85. So again, you would just enter those in your calculator to get the decimal approximations. And for decimal answers, I accept them to 2 decimal places of accuracy is typically fine. Okay, so let's do another example, and then we'll talk about the discriminant, which will describe the nature of the solutions for the quadratics. So again, one more example. So let's solve. Sorry, I keep hitting this button. I'm left-handed, and this little writing tablet has a sensor up there. So again, let's solve 7x squared minus x minus 2 equals 0. So again, if you wanted to check and see if it factors, you'd multiply first and last 7 by negative 14, and you can inspect the sum like we did last time and notice that none of those factor, right? Remember, you have to use the AC method or first and last method to determine factoring. So you multiply the first coefficient 7 by the last one 2, and you would get negative 14, and you'd have to find 2 numbers that multiply together to negative 14 that add up to 1. So if you look at the factors and the sum, essentially there's not too many options. You could have negative 1 and positive 14, which adds up to 13. You could have positive 1 and negative 14, which adds up to negative 13. You could have then 2 and negative 7, which is negative 5, or negative 2 and positive 7, which is positive 5. So none of those numbers is equal to negative 1, so that indicates that this will not factor. Again, let's remember the quadratic formula. Basically, x equals negative b plus or minus the square root of b squared minus 4ac divided by 2 times a. So we're going to use that to solve this equation. Here a is 7, b is negative 1, and c is equal to 2, negative 2. So don't forget about those negatives. So the answer to this, or the solutions, would be, again, opposite of b. Since b is negative, this first term will be positive, positive 1, plus or minus. Again, b is negative, so we need to make sure we include parentheses. Negative 1 squared minus 4 times 7 times negative 2 divided by 2 times 7. And so that means x is equal to 1, plus or minus the square root of 49 plus, what do we have here? 8 times 7, 56, over 14. So we have x equals 1 plus or minus the square root of, that comes out to 105 over 14. So our solution set is 1 minus square root of 105 over 14, or 1 plus square root of 105 over 14. Right, and we can get the decimal approximations as we typically like to do. So the first one comes out to minus 0.66. And the second one, 1 plus the square root of 105. I mean, if you're doing it in your head, you know it's going to be slightly less than 1 because the square root of 100 is about 10. So it's going to be somewhere close to 11 over 14. But not exactly. So you want to do it in your calculator to be sure. So this comes out to 0.80 if you round to 2 places again. So that's only 2 places of accuracy. So those would be your 2 answers to this typical example. Okay, so we'll have a few of those on the homework, and there's some other examples I may show you, but it's, and even if you know how to factor a problem, you still can use the quadratic formula and you'll get the correct answers. A lot of times, though, it's just a little bit more work to use this method, and it's good to be able to factor and use the quadratic formula. So let's talk about the discriminant. So the discriminant, oh, I didn't spell that quite right, did I? So discriminant. So the discriminant is essentially just the quantity that's below the square root in the quadratic formula. So it's, if you just look at b squared minus 4ac, that is the so-called discriminant. And what it tells us is it tells us what kind of answers the equation has. So, I mean, the examples we've looked at so far, they've had 2 answers, but it's possible to have 3 different types. I mean, if you think about the graph of a quadratic, remember it's a parabola, and what can a parabola do? It can cross the x-axis in 2 places, which are like the ones we've seen so far. It can be tangent to the x-axis, so you could have a parabola that just touches the x-axis one time, or the entire parabola, it can open upside down as well. Maybe it goes completely below the x-axis and never touches. So there's three possibilities for the equation. You could have two solutions, one solution, or we could have no real solutions. And if you're working over the complex numbers, this would mean actually that there's probably two imaginary solutions, but we probably won't get into that here. For the purposes of real numbers, though, this won't have any real solutions. So if you look at that discriminant, when is this going to happen? Well, if b squared minus 4ac is greater than 0, that's when we have two solutions. If b squared minus 4ac equals 0, we have one solution. And if b squared minus 4ac is less than 0, we have no real solutions. So you can look at a quadratic immediately and tell if it has any solutions. So, I mean, we could just give some quick examples. Let's say we had x squared plus 1 equals 0. Well, there's no x term, so this would have, say, a would be 1. There's 0 x's, so b would be equal to 0, and then c is your constant term, 0. So if you do b squared minus 4 times a times c, in this problem you would get 0 squared minus, c is equal to 1. I don't know why I wrote 4, or 0. I think I thought 1 and wrote 0 somehow anyway. So we'd have 0 squared minus 4 times, I don't know why it does that. It defaults to blank color. 0 squared minus 4, come on now. So minus 4, I cannot tell what is going on here. Doesn't want to write. Okay. Anyway, okay, sorry, back again. Some technical difficulties with Paint, but so we would have 0 squared minus 4 times, and c was equal to 1, sorry, 4 times 1 times 1. So we would end up with 0 minus 4, which is negative 4. So that tells us that this equation up here has no real solutions. So try and think of examples where you might have the other possibilities. Maybe try if you had, so if b squared were equal to 4ac, so maybe b is equal to 2, because 2 would be that, so maybe 2x squared. So you have b squared minus 4 times a times c. So, oh, sorry, I wanted b to be 2. So excuse me. So let me just do that down here real quick. So if you had, say, x squared plus 2x plus 1 equals 0. Here, b squared minus 4ac would equal to 0, so this should have exactly one real solution. So you could use the quadratic formula to go ahead and solve that, and you should get one solution, but we know that actually works because this would factor into x plus 1 times x plus 1. So the single solution to this equation is just x plus 1 equals 0, or x equals negative 1. That would be your only solution to this equation. So that's it, and we'll go over some more quadratic formula examples for practice in class on Wednesday. And this is Dr. Delennon signing off.